Let's try to find the inverse of this function. Start by setting y equal to x minus 5 divided by x plus 1. To find the inverse function, we switch the x's and the y's. So whatever was an x becomes a y, and whatever was a y becomes an x. So the equation becomes x equals y minus 5 divided by y plus 1. And now what we need to do is solve this equation for y. And we'll have found the inverse function once we do that. Okay, so to clear the denominator from the equation, let's multiply both sides times y plus 1. So the y plus 1 distributes through the equation. And on the left it ends up being x times y plus 1. And on the right the y plus 1's cancel, so we're left with y minus 5. Now we distribute the x through the parentheses. And we get xy plus x equals y minus 5. To solve for y, we need to get all of the y terms together on one side of the equal sign. So, let's take away xy from both sides. That brings all the y's to the right, so I'll also add 5 to get the 5 on the other side. So the y terms will be on the right, and everything else will be on the left. What we end up getting is x plus 5 equals y minus x times y. Now we can factor out the y. So we have x plus 5 is equal to 1 minus x times y, because y times 1 is y, and y times negative x is negative xy. Finally, if I divide both sides by 1 minus x, we will have solved for y. So dividing both sides by 1 minus x, we get x plus 5 divided by 1 minus x is equal to y. This means we've found the inverse function. In fact, g inverse at x is precisely this function, x plus 5 divided by 1 minus x. And we've found the inverse function, which means that the answer to our question up here is yes. And we found it. The function is invertible.